G'day guys, today I'm going to go through how to make videos from figures inside Matlab. Alright, so let's get into this straight away. So the first thing you're going to need is some form of data set. The data set can be from any one of a range of different things. Generally though, you want something that's going to change over time, which is the reason for creating these sort of videos. The data set I've used today is a data set that's come out of a video I made in a tutorial in a game called Rust. The idea of the video that I'd made was to look at the power generation of solar panels inside that game, analyze them against different angles to determine what is the optimal angle for generating power inside the game. Now, what you see up on the screen there is, I guess, part of the final product. I'll put a link to the actual final product video so you can have a look at how it's all come together. But one of the things I did when I was gathering my data is took screenshots inside the game at the time. Once again, it depends on what sort of experimental data set that you're actually using as to whether this sort of technique's appropriate. So it could be, for example, photographs, and you've taken a progressive set of photographs over time and you want to plot some form of data. Maybe it's a water flow through something, and you've got videos at the same time that you've taken velocity, flow rates, whatever the data is. In this instance, I've just taken photos inside the game throughout the day, and then at those times measured the different outputs of the solar panels and also integrated over time to give a total sum. Now, if you have a look at the screen over here, there's two bits that I've added to it, and I'll show you how to put all this together in the video. If you don't want some sort of background picture like this in your product, then just omit the steps where I actually add the pictures in. Just omit those and instead just go straight to the plotting to give yourself the plot. So this is the plot over time. Each one of these indicates a data series that changes over time, and as the video progresses you see these going up in live with the video. Additionally, at the same time, and one of the other bits, if you don't want it, don't put it in, is live data from the integral of the power over the time as an indication to get to show what actually was the most efficient over that day. Alright, without further ado, let's get into having a look at the actual script that's created this. To do this, obviously, you're going to need a little bit of basic knowledge in Matlab, but not too much. This script, pretty much you can copy and paste bits from it directly and they should work for you. If you have any issues doing any of these things, just hit us up with a message and I can see what I can do about helping you out with those individual specific bits. Alright, so to start off with, you need to start, I guess, and set up your video recording, which is done in this first bit of the script up here. If you set no directory onto this, this will just output straight into your selected Matlab folder, and this will be the video name when you create it, and this is the file type. There are a number of different types, but if you're using a modern version of Windows, which I kind of hope that you are, MPEG-4 is what I'd recommend for these sort of videos. The next bit that's really quite critical is the frame rate. Now, for my application that I've used in this video, I picked a frame rate that to me looked alright and gave the sort of effect I was looking for. But if you're doing stuff against live time data, what you want to do is work out what your delta t is and divide 1 by your delta t to give you a frame rate. Therefore, if your delta t for whatever either your data set or your functions is say 0.1 of a second, then if you work with a frame rate of 10 frames per second, then you're going to come up with a live view of whatever's happening in your scenario. Taking that's obviously a live view. You can then dilate or contract that as required to produce I guess an either sped up view of what's happening if you've got something that's got a very long time period, or slow down stuff if you've got a lot of data points and you've got something that's happening really quite quickly and you actually want to visualize what's happening. This though, setting that frame rate is really quite important for whatever output type video that you actually want and your specific applications. All right, moving on from there, and I'll just close down the for loop at the moment, which actually creates frame by frame the video. And you'll note there's two bits, open and then your write object, which is your video configured stuff, and then you close. You need both of those to make sure that the file's both opened and then closed correctly at the end of it. But all right, let's get inside the for loop and have a look about what those bits that you need inside there. So the first bit is, I've displayed an image. Now, you don't want to individually select the images as you go through over the time of this thing, otherwise it's an extremely painful process. So what I recommend you do is set up some sort of naming system for your files such that you can, iterate through them. So as your series goes through, it then picks up the new name of each of the files. What I did to make life easy for me is I took those pictures that I showed you against time. So it was taken over time. Because of the screenshotting software that I'm using, it indexed time each time I took a picture. So then I converted those file names into a file name of just how many seconds had elapsed since the start of the series. So for example, the first image was 0, this 0.jpg, the second one was 15.jpg, then 30.jpg, 45, so on and so on and so forth. With my first data series, and also my X in this instance, being those same values. So what it then means is you can put together a string, which this image name here is, which firstly has the directory that you've saved those files in. In this case, I call the directory solar. And then the changing part of the name, in this case for me, it was the X value, and then lastly, append the JPG onto it. From there, just name the object and then show the object. So that will actually bring it up in a figure. From there, you want to hold that figure open, so throw your hold on. And then in my instance, I wanted a second set of, a second figure inside there, which is my axes showing the actual power generated at time. So create yourself another set of axes if that's what you want. And then from there, plot your data. Now, obviously mine's got a lot of different data sets in it. Each one of them's just drawing out a different line for the Y. So the X's are all the same for all of these. And then the Y's will change. So this is obviously my data set 1 from solar panel, the first solar panel, the second solar panel, third, fourth, fifth, sixth. Now you note I've gone 2, 5, 8, 11, 14. It's pretty much because I had more data than I wanted to display on that graph. So I only picked every third one as it is. All right, so moving down, you throw X and Y limbs on for this, which cover the data set for that entire period. The reason you want to do this rather than just let Matlab determine this for itself is you don't want your axes changing over time, or at least in the video that I've created, I don't want it. I want it to just, the lines grow over time without the actual graph changing its axes. If you want a different effect, just delete these lines. But this should be for your maximum, minimum Y value, minimum, maximum X value, and you'll end up with the plot being the same for the entire time, the scale being the same, and then the data will just appear as the video progresses from there. All right, so I created, as you saw on the other figure, a second box, and that second box I wanted to display the integral over time of all the different solar panels. And that's what I've done here. So I've just created a secondary box. If you're having a bit of trouble working out the position data, so whenever you create an axis, you need these 4 position points, the X and Y's of 2 of the corners. If you're having trouble actually putting this together, one of the things that I can recommend to get this on there is draw yourself a box on a figure. So copy these first bits, whether it be your image bit, copy it, paste it into the Matlab window, generate a figure that's obviously the same as the one that you're going to output, draw a box on it, right click on the box, and then bring up the show code. By doing that, when you show the code, it will show you the position data for the box you've drawn. So as long as you're drawing the box in the spot that you want it, you're going to end up with the right position points. From there, I've then inputted data onto it, and you'll see I put a lot in there. So it was every 10 degrees in orientation, I had a different solar panel, and that's what each one of these ones is inside here. So I got firstly the title for it, and then following to that, adding the individual text on there. Once again, just so you can actually see what I've done here, in case you want to use something similar in one of your projects, is I've created a string bit of data which has a text element to it, in this case east, and then the second part of that is the specific value rounded up to an integer. And then from there, that's just straight inputted into a position. Note, these position plots that you're going to be adding here are positions inside this created set of axes up here. So you need to be mindful that it'll start at 0, 0 in the bottom left-hand corner of that drawn axis and go to 1, 1 at the top right-hand corner. So if you work with that, that should give you a decent indication of where to put the bits in there, but a little bit of experimentation should help you. One of the ways that I find that's good to experiment is you copy all your code except for the right video. So from here, in this instance, to here, copy this, paste it into the main Matlab window and hit enter. That will then produce a figure which is the same as the figure that you're going to output, so you can tweak bits without having to generate the whole video and then change it later, if that makes sense. All right, so the last bit of this is the right video, and then obviously clearing the hold on that you put on earlier. And this is quite simple. All you're doing is just the writer object that you created up the top, get frame GCF. This will pull the current frame that you have, and then that's pretty much it. It'll copy that frame, insert it at the end of the video as a new frame, and then the last bit is to have close all. And you don't really need close all, but the reason I put it in there is every now and again, if you don't have it there, you can have stuff from the previous draw continue into the next one. So every frame, you really want a fresh frame to be created, drawn, to make sure there's no hangovers, just in case there's something goes wrong, which I'll tell you now, unfortunately, it does at sometimes. So just close everything, and then on the next iteration of the for loop, it will then reopen a new frame with the image that you've then loaded up for your next one, and so on and so forth. All right, guys, what I'm going to leave you with now is at the end of the video, I'm just going to attach the video that's created out of this script so you can have a little bit of a look at it. But once again, if you've got any questions or there's other Matlab or Octane type tutorials that you want created, just hit us up and I'll do my best to create those for you. But otherwise, guys, have yourselves a great day.